Forget everything you think you know about wealth. Forget everything you think you know about wealth. Forget Silicon Valley. The next trillion-dollar frontier isn't on Earth, it's millions of miles away. Asteroid mining sounds like a dream, but it's quickly becoming a very profitable reality. The next great fortunes will not be made on Earth. They will not come from digging in the ground or drilling beneath the sea. The next trillion-dollar opportunity hangs above our heads, silent and waiting in the vast darkness of space. We are standing on the shore of a cosmic ocean, ready to set sail for islands of unimaginable riches. These islands are the asteroids, the leftover building blocks of our solar system. They are more than just space rocks, they are the keys to our future, holding resources that could change everything for humanity. Imagine looking up at the night sky. You see the moon, a few planets, and countless stars. But between those familiar points of light lies a hidden realm, a belt of rock and metal. This is the beginning of a new chapter in human history. History is filled with stories of gold rushes. People once risked everything to cross continents and oceans for a chance at striking it rich. The California gold rush in the 1800s changed a nation. It built cities, created fortunes, and fueled an era of expansion. Now imagine a gold rush 1 billion times bigger. This is the promise of asteroid mining. It is not a rush for a few nuggets of gold in a riverbed. It is a rush for mountains of precious metals floating freely in space. The potential wealth is so vast, it is difficult for our minds to even comprehend. The asteroids in our solar system are not all the same. They come in different shapes, sizes, and compositions. Some are mostly rock, but others are made almost entirely of metal. Think of an asteroid a single kilometer across. It could contain more iron, nickel, and cobalt than has ever been mined in all of human history. So what are these cosmic treasures we speak of? The value of asteroids goes far beyond shiny metals. They are divided into different types, each with its own unique bounty. Infographic shot, C-type, water droplet icon, infographic shot, S-type, smartphone icon, infographic shot, M-type, gold bar icon. The most common are the C-type or carbonaceous asteroids. They are dark and rich in carbon, but more importantly, they are full of water. Water in space is more precious than gold. You can drink it, of course, but you can also break it down into its components, hydrogen and oxygen. This gives you breathable air for astronauts and, crucially, the most powerful rocket fuel we know. Then there are the S-type or stony asteroids. These are made of silicate materials, but they also contain valuable metals, nickel, cobalt, magnesium. But the real prize for our modern world are the rare earth elements. These are the elements that make our technology possible. Your smartphone, your EV battery, medical devices. The rarest and most sought after are the M-type asteroids, giant flying chunks of pure metal. A single, modestly sized M-type asteroid could contain metals worth trillions upon trillions of dollars. Before we can mine an asteroid, we have to find the right one. Finding them is like searching for a specific grain of sand on all the beaches of the world. Great telescopes on Earth scan the skies every night. Great telescopes in space scan the skies every night. They are our celestial cartographers, mapping the unseen landscape of our solar system. They spot the faint glimmers of light from distant rocks and track their paths. Scientists use a technique called spectroscopy. By breaking the light into a rainbow, we can read the asteroid's chemical signature. This allows us to create a catalog of potential targets. We can sift through the millions of space rocks to find the few that are truly valuable. And easy-to-reach trajectories help narrow the list. Finding a promising asteroid is one thing, getting a closer look is another. Mission OSIRIS-REx. Mission Hayabusa 2. They entered orbit and mapped their worlds in stunning detail. They touched down and collected samples to bring back to Earth. Mining in space is nothing like mining on Earth. You cannot just send a crew with shovels and dynamite. The environment is one of extremes. Zero gravity, vast temperature swings, dangerous radiation, zero gravity rules. To succeed, we need to invent a whole new set of tools. The heroes of this new industry will not be rugged miners, but brilliant engineers. These machines must be tough, smart, and able to work on their own, far from any human help. They will be our hands and eyes on these distant worlds. Imagine a robotic spider, capable of anchoring itself to a spinning asteroid. It could crawl across the rock, using lasers to analyze composition and find the richest veins. Or picture a swarm of smaller robots that work together like ants. They could carry regolith back to a central processing unit. Processing in space avoids the cost of bringing raw rock home. Using processed asteroid material, we could 3D print tools, spare parts, and even habitat modules, creating shelters for future human explorers. The dream of asteroid mining is inspiring, but the reality is filled with honestly just monumental challenges. The first and biggest hurdle is simply getting there. Space is vast. The journey to a suitable asteroid can take months or even years. This requires an incredible amount of fuel and advanced navigation. The cost of launching such missions runs into the hundreds of millions or even billions. This is not an industry for the faint of heart or the small of budget. Once you arrive, the environment itself is a constant threat. The vacuum of space is unforgiving. Radiation can fry electronics. Temperatures can swing by hundreds of degrees. Asteroid dust is sharp and abrasive. It can clog and sandblast machinery. In microgravity, simple digging would push you away from the rock. Newton's third law is the law of the land. Mining equipment must be securely anchored, which is difficult on a tumbling, oddly shaped body. Drilling could change its spin. Finally, bringing treasure home is non-trivial. Re-entry is violent. We might instead park refined metals in orbit to be used for in-space construction. As we get closer to making asteroid mining a reality, we face a question. Who owns this new land? Who owns a rock floating in space? The foundational law of space is the Outer Space Treaty of 1967. It was signed by most nations. The treaty is very clear. No nation can claim sovereignty over a celestial body. But the treaty is silent on whether a company can own resources it extracts. Some countries have acted. United States, Luxembourg. They argue this is like fishing in international waters. A company owns what it catches. This makes other nations nervous. They worry a first-come, first-served system will lead to a cosmic land grab. Others argue space resources are the common heritage of mankind. They propose creating an international authority to govern asteroid mining, to distribute profits fairly and set rules of the road. Before the first robotic miners start digging, the nations of Earth must come together and write the rules of the road. The future harmony of our species in space may depend on it. The immense value of asteroids creates a powerful temptation. It could spark a new space race, very different from the moon race of the 20th century. A race for asteroid resources would be about economic power and strategic advantage. Nations that control asteroid metals would hold immense influence. Imagine two companies from rival nations trying to mine the same asteroid. What happens if their robots interfere with each other? Without clear international laws, disputes could escalate quickly. The stakes are high. The technology used for mining, powerful lasers, autonomous robots, advanced spacecraft, could have military uses. The line between a tool and a weapon could become blurred. We must be careful our quest for riches doesn't export our conflicts into the heavens. The best way to avoid this future is through cooperation. The challenges are so great it makes sense to work together. International collaboration has already been a hallmark of great scientific achievements like the ISS. An international consortium could ensure benefits are shared, funding development, research, and lifting communities. This would turn asteroid mining from commerce into a project that lifts our species. Let us take a moment to dream. Let us look beyond the challenges and imagine the world that asteroid mining could create. This is not just about cheaper smartphones or more electric cars. It is about a fundamental transformation of human civilization. The resources of the asteroids could usher in an age of unbelievable abundance. Scarcity could become a thing of the past. With limitless energy and materials, we could solve poverty, pollution, and more. This new era would fuel a technological renaissance. Imagine giant solar power satellites miles wide, assembled in orbit from asteroid iron. We could build vast spinning space habitats, cities in orbit, built from materials that never had to be launched from Earth. Asteroid mining is the essential first step to becoming a true spacefaring species. The asteroids are our stepping stones to the rest of the solar system. By using water for fuel and rock for building, we expand our reach. Moon, Mars, and beyond. The asteroid mining revolution is not just about what we will find out there, it is about what we will become.